I work for Polidea. This is a software house situated in Warsaw, and I've come here to give you a talk about how hard it was to build an RX library. Well, I will share this information from 3 points of view: the users, the developers, and potential maintainers of the library. Maintainers or external contributors. Now, a question: is here anyone who did not encounter RX Java or any reactive library before? Yeah, I see one hand, though I'm not really sure. Okay, all right. So I will skip. Yep. A second. So I will skip the introduction to RX Java. I will just emphasize one thing that I think that is the most important part of reactive programming. When we have an observable that is emitting an item, for instance, if we are having a production line of bottles, and a single bottle is being established, is being produced, then we can apply a function on it. For instance, make it red. And from that point of view, usually the user is not interested in the original observable that he started with, but only with the observable that is already transformed with a function. So he skips the production line, he just wants to have a red bottle. And on that red bottle, he can again apply next functional transformation, for instance, fill it with water. And again, after filling with water, he's not interested really in how he came to the point when he has a production line that is producing bottles that are red and that are filled with water. It's a straight functional situation on which it is easy to define what is the input of a function and what is the output of a function. And having a strictly functional code gives you a lot better handling of potential problems that may arise during the execution. All right, so in 2000, to give you a bit of a background of what I was doing past 1.5 years. In 2010, Bluetooth Signature Group has incorporated a new standard to the specification of Bluetooth, namely Bluetooth Smart or Bluetooth 4.0, Bluetooth Low Energy. These are the names. And this is a quite new standard for radio communication with low energy devices. It is aimed for low energy communication between usually smartphones and IoT devices. The thing is that this whole specification is quite large. It has more than 4,000 pages, and it's not that easy to get right. If you would put in Google BLE issues, you would get probably tens of millions of results for that query. Yeah, to give you a bit more introduction to that, as it is a wireless communication, it is involving a radio adapter that is an entry point for all other interactions, namely for discovering the devices that are nearby, or for connecting or communicating with a particular device. And yeah, when discovering a device, there is of course a device that is in question, and this device is described with a GAT generic attribute profile named GAT. This generic attribute profile has basically all of the attributes that are possible to alter on a device. It consists of services. The services are basically the functionality that a particular device or a GAT profile offers to the user, to the client. For instance, a service could be a heart rate monitor, or a weight, or a cadence monitor for cyclists. Every service contains many characteristics, may contain many characteristics, which are basically the entry points for all of the communication. And the characteristics are the kind of a buffers that you can write information on to read information from, or to set a notification in two ways, that a particular device will give you a proactive notification when a value of a specific characteristic will change. And there are many other attributes. There are also descriptors for characteristics. The descriptors are basically describing what a particular characteristic does. This is not really important. The thing is that these all attributes are quite cumbersome to use when dealing with the native Android API. Just to give you a few examples. When dealing with a radio adapter, before you can use it successfully, you need to check 3 states. First, if you have the permission for using the Bluetooth, quite obvious. Secondly, you need to have a permission for locating a user, because this is not so obvious, but having a Bluetooth beacons which position is known, you are able to track the user's location. But even then, to use Bluetooth and scan the devices that are nearby, you still need to start GPS location, or you will get no results without any error. So this is how it works, but it doesn't follow the functional paradigm, because there are many places, outputs that you would need to check to get the actual state that you are in. There are more situations like that. For instance, when dealing with characteristic reads or writes, you can have a situation that particular permission will be revoked, or a Bluetooth adapter will be turned off. And when dealing with only a characteristic, you will have no information why there is a timeout. Or you will even get no timeout, because some state in a different place of the API has changed. And there are more situations like that. Reading a characteristic, but the connection was being dropped. Again, no information on the characteristic about it. This is something that usually was the main culprit for applications on Android that were not getting high ratings because errors on the communication level. All right, so when dealing with a new RX library or writing one, the very important part of the process is to define the abstraction, because as you may imagine, the Bluetooth specification is quite good. Like is very solid, though it's very large and like generic attribute profile. It is not something that people tend to have experience with. And maybe there is something that some way of describing it that will help in successful understanding of what is going on and how to work with it. So I've started building the library in 2015, and it was not the first. It was not the first attempt that I've taken upon that was good enough. When there are many layers of the protocol, the Bluetooth adapter, the Bluetooth device, and the GATT, usually when people are trying to write a new RX library, they're just wrapping the interface that is already there. So that was what I did. And yeah, there were Bluetooth client, Bluetooth device, Bluetooth GATT. I was able to squeeze some more information, make the API more functional, but still I would get a Bluetooth GATT packaged, wrapped, but still it can be in different states. It can be connected, disconnected. I would need to connect or disconnect it. This is something that needs to be managed by the user. And the more states that the user needs to manage, the more likely, the more prone is the application to have a bug. So the other problem was that having this abstraction was not really meant to fit into an actual implementation that would work flawlessly. I have spent around 3 weeks playing with a prototype with that, and it was no go. So I fiddled a bit with the thought that, okay, I need to connect the GATT and disconnect it. So maybe the GATT isn't that really important. Maybe a different abstraction will be better. I have came with Bluetooth connection, and that is something that feels better. So still, is the connection connected or disconnected? I would need to connect the device to get the connection. A bit better, but still not best. And after a while, I thought that, hey, maybe a user is not really interested in how to connect. Maybe they just want to get connection at some point. And just to establish a connection. And the connection itself stopped to be something that is always there. Like the connection is only a result of an emission of calling RxBLE device establish connection. In this situation, this is purely functional approach, which does not have any side effects. Just call the function and get the connection. And the thoughts that came after were that simple wrapping is usually not enough for Rx libraries. That you can do better. And sometimes you need to propose something completely different from the abstraction that is already there. You need to experiment a bit to find what works best, and you should aim for most stateless functional interaction, because what is going on is that the state is hard. State is the main culprit for the bugs that can happen. A great example of a stateless interface is a HTTP connection. It can be imagined as a tunnel. It has only an input, an entrance, and an output. It has no states. Just you can safely open several HTTP connections and you can be sure that they will not interact with themselves. There will be clear separation of concerns. So when we have our abstraction, we should go to define the API. And when I have started working with the library, there was only an RxJava in version 1.1.0. And the only possible interface to use was an observable. So here is a part of the interface of the connection from that time. You could read a characteristic, write one, set up a notification, read descriptor, or write descriptor. What you can see here is that there are observables basically everywhere. And apparently, some of you with good eyes can even see that there's an observable that emits observables. But sometimes this abstraction works. Usually, users were quite confused when finding this interface. How many of you tried a new library strictly by looking on the API? Okay, I think that the rest of you first look on the specification or the documentation of the library. All right, that's what I thought. So the users that were using the library asked for, like, hey, could you specify a bit better what is going on when I have a specific observable returned? Well, yeah, I did this table, but again, the user would need to find it, and it was on the README. Not really ideal situation when people come and need to dig through the documentation to find what they will get. So currently the RxJava or all others reactive libraries have matured, and there are more other interfaces that we can use. Observables, singles, completables, and maybes. Well, these are all just special situations for observables. Single just emits one value or emits an error. A completable just completes or emits an error, and maybe will emit, or maybe not. Even then, when we see this, that we have more possibilities, it's good to play with them. So the old API would become the new API. A whole lot easier to understand only by looking on the API, only by playing with a library. This one change has impact on both users that will spend less time getting into the speed, getting to the knowledge of a particular library. Plus, it will save the time of the developer adding new documentation somewhere. Okay, so we have our API, but we firstly introduced one interface, and then it turned out that it does not really work that well, and we should introduce another one. The thing is that users, when once made their code work, will not want to revisit the same part and to add to change their code to use the new API. And for the users to know where they can when they can safely update a library without the need of touching the code, there's a well-established way of doing that in the industry. It is semantic versioning. for when I have started, I didn't really pay attention for that. And sometimes I had situation when I have updated libraries that were only patched, and I needed to change the API. Not really convenient. Okay, so what can we do with the semantic versioning? Semantic versioning consists of 3 parts: the major version, minor version, and the patch version. On the patch version, only implementation changes are allowed. Nothing in the API should change. On the minor version, we can make ABI changes. What is the ABI? I have learned only recently. And the ABI stands for Application Binary Interface. This is basically an API for your compiler. When we type the words in an IDE, we type with the API. When the compiler starts the work, they transform the API call to the ABI, where a particular address of the file is used to execute code. The same goes for changing the signatures of functions, method, or interfaces, public interfaces. Even changing the call from a variable of a parameter that comes to a function to a var parameters changes the ABI. Okay, and on the major, you can basically change all of the API, remove the old one, whatever you want. The thing is that users do not like do not like when the library changes majors too often. So, unfortunately, if you have introduced an interface at one point, you should support it for at least some time. But we can do something with that. The thing is that we should think about it before we release a new interface. We should ask ourselves what should be exposed in the public API. How to expose a smaller surface of the API. Will it be possible to translate one API to another seamlessly under the interface, so the user would not know that something has changed under the interface? And in the industry, we often hear that it is possible to start an application from the minimum viable product. The same goes for the libraries. When you start with only small amount of effort, but you will be able to secure use cases of a majority of the users. All right, so then we are coming to the phase 3. We have our good abstraction, a small surface, but again, for our green pastures, there will come a user and will say, all right, but I need to change something in how your API works. I would like you to add me a parameter in the interface. I want you to add me some knobs. Okay, so what options do we have? We could basically expose all of the knobs in the interface. And having an interface that is easy to work with for the novice users will have no parameters. But then, for instance, we can have 2 different parameters that will alter in some way how the API behaves. Okay, but what if the user would like to change all of them? In this situation, we would have 4 different method calls that would do basically the same. Okay, but what if we would get another parameter there? The number of methods will exponentially grow. and we would need to support it. The interface will get bloated, and when the new user will come to your library and will try to use it only by looking on the API, they will get a bit confused. But this is a valid approach. Some libraries use it. For instance, the X.YZ. When you will come to the API, you will see that it has, I don't know, somewhere around 100 functions. And so, yeah, it's possible to use it. And the other option is to use a telescopic constructor pattern. Used mostly in the constructor pattern of classes in Java, but it's easy. We have only one method that is doing actually something, and then we have other methods that are just like a telescope that are enhancing the same call with different parameters. Okay, and there are even more patterns. What apparently worked best for the Bluetooth communication was a strategy builder pattern. So we would have a simple method that would be suitable for most of the users, and a version that would use a strategy. And a strategy would contain the default values for the calls. Having a builder with that may gives the user ability to learn the usage of the library only by using the API, because they will see that they need some strategy. The some strategy would have a builder, and builder would have only the methods that are relevant to this particular call. So, having there is no silver bullet for that, but having to know what options do you have, you can think in front about what is the ideal solution, because then you will again save the amount of time that the user takes to use your API and the amount of time that you will lose for supporting them. All right, so even then, this is not all. Sometimes the API will just inform the user how some functionality is working. But functionality is not all. Sometimes there is more than that. This is called domain logic or domain knowledge. This is something that you cannot learn only by looking on the API of a library. For instance, in Bluetooth communication, it is the state that you need to manage. And you need to call the native API in a particular way. To make it easy for the users, you can take one of two strategies. Apparently, when dealing with actions on the Bluetooth radio, the radio can only execute one action at any given moment. But it's quite easy to implement a queue just for them. And they will have no information about how it is executed. If they are interested only in executing an action, it will happen at some point in time. The rest is handled for them. But it's not always the case. When a user would try to establish a connection to a device, they will establish it at some point in time. But some people do not know that Bluetooth specification says that only one connection can be established to a given device at any given moment. So if they will try to establish a second connection, what should happen then? We could again say that, hey, we have already a connection opened, so here you go. And they will try to use it. The problem is that this connection usually in Bluetooth communication there is a request-response model being used. The thing is that the request-response model is stateful. It is a response for a given request. When trying to execute 2 requests at the given moment, it is possible that the responses will get mixed. And this may lead to hard to debug problems with the code of the user. Okay, so what can we do? We can also try to postpone the establishment of the second connection until the first one will finish. And this is a valid approach, but still users will get distracted because their connection will not be established for an unknown amount of time. It will only be established when the first connection would get closed by any reason, an error or just disconnected. So in this situation, the best idea is to inform the user proactively that something is doing wrong and to give him an exception that, hey, you have already established a connection. And then they can follow the code where the connection was being established. And then it's easy to use X.YZ to share the connection just by calling the share operator. But informing the user that they are trying to do something that is not supported and is not supposed to be done is really important. It's really important to give them meaningful feedback. So if your library is encountering an error that is happening somewhere below, it's quite important, if you know what is going on, to wrap it up and give a good explanation and preferably a link to the knowledge where the user can establish their knowledge about a particular topic. In my case, it was something called a GAT status error. When connecting to a device, a lot of different errors may happen. And one of them, it was the GAT error that just showed a particular integer value. And it was hard to find the reason because it was not documented on the Java API. Later on, I have stumbled upon in the Android source files a header file for a header of a C file, and found out that every single error is described there. So I thought that, hey, maybe this will help. And suddenly, after deploying this little change, when printing the exception, a lot less people came to me to ask what is the problem. And this will save your time and, again, the time of your users. Okay, but educating your users is the not only thing. Because usually when you are trying to build something, this is not necessarily a library and not an Rx library. Maybe some module that not only you will use, but also people that will come after you to your work. And sometimes you will see in the code that, all right, we have some class that is verifying scan preconditions. Okay, it's for AP24. And it uses the same class, but only for the API 18. Fair enough. And there is another call that is checking if it was not called too many times. And when a new contributor or a new maintainer comes to your code, it has no difference for them if that will be checking a specific parameter of the code. It's just a magic number. They have no idea why it has been put in this place at the first place. So we all should aim for self-descripting code. So to get the reasoning about what is going on as easy as possible to the future you or the maintainers or contributors that will come. But there is nothing I could think of that would get around just giving a plain old-fashioned comment in the code why something was being put in a place. A good idea is also to put a link to a place where more knowledge is being stored. All right, so who of you have ever put a commit message like this? Reverted behavior changes or fixed a bug in? Okay, what do you know about it? Okay, it will fix a bug. But what bug? Why did it happen? Where was it introduced? Well, you do not really know. This is a bad solution. A bit better solution is to give at least a link to the information where more knowledge can be found. It is a reference to an issue somewhere. But okay, it's better. Still, the information there, the link may be inactive, or the person who is looking at it may not have access to a particular site. So there is something in the SVN applications that allows you, that makes the application treat the first line of the commit a bit differently than the rest. So here, the first 60 characters or the first line would be always shown as a title, but still the commit message may be arbitrarily long, and you will not see it until you will come into the details of a specific commit, and there you can have a full backlog of the information that you need to understand what has changed, why has changed, and because people could have only reason about your log, about your code by checking, by blaming the repository and checking what has happened on which commit. This turned out to be really helpful for the maintainers and for future me, because after half of a year I do not remember what I have done in the library. And last but not least, tests. Tests are extremely important, especially in any long-running project. Without the tests, it bit me hard many times that I did not start the tests as soon as possible. The tests are the safety net, your only safety net before regression, and for all your maintainers that will come after you, and they will have not the same domain knowledge that you have. This is an ideal solution is, if you find a bug, you always, first thing that you do, you put a new test for that particular bug, and only then you start to fixing it. All right, so to wrap things up, from my experience, which I've gathered during 1.5 years of developing the library, it turned out that there are some parts that are really important to do at first. So try to model your API in the most natural way of the interaction, because people will not try to, usually people will not try to first use your documentation to learn about the topic they are going to touch. Secondly, aim for stateless interactions, because this gives you the power to model the interactions, the data flow, only in one place. And it's then really easy to track a bug and try to avoid it. Moreover, when designing the API, it's good to think about the size API before building it. And think about the usage, simplicity of the usage. If it will be possible to at least learn the API only by checking the header files. And think about the potential enhancement points in the code. And last things is to do not make the access to the domain knowledge harder for both you, your future you, your users, and the maintainers. Always leave as many breadcrumbs to the domain logic as possible, because then it is a way easier to find what the change or what is the reasoning behind some decisions in the code. Test as much as possible and as soon as possible. And also pick your battles to know where it is the best solution to manage problems for your users and for you, and when it is best just to tell that something went wrong and what went wrong. All right, thank you very much. And do you have questions?
So my question is, because this library is open source library, right? And people say that just put it as open source so that community will help you develop the library. And my question is, are there any committers from community? Is someone helping you with this library, or is it open source and you are doing the whole work?
Well, yeah, it is open sourced, and there are contributors that come and try to help. Usually when they have something that they would like to have in the library, but they do not find it before. There were 3 or 4 of them that actually helped in the development. But there are a lot of people who have found some kind of inconsistency in the documentation, or some other minor problems in the code that didn't really need it to understand the whole to help. There are about 20 different contributors by this moment. Any other questions?
Do you have any competitors on the market? I mean, other open source libraries that are the same as yours?
There are. The question was, are there any competitors to my library? And the answer is yes and no. Basically, there are libraries that also touch the Bluetooth, but usually it's not the Bluetooth low energy. There is an RX Android library that touches only RX Bluetooth library that touches only the Bluetooth communication, and there are other libraries that touch Bluetooth low energy, but they are not reactive. And from what I have seen up till now, the library that I have started to develop is the most recognized one.
Questions?
Okay, so in this situation, thank you very much.